Hello everyone. First of all, thank you very much for attending this presentation. My name is Diana María Naranjo Delgado. I'm a PhD student in the Grid and High Performance Computing Group at the Universidad Politécnica de Valencia in Spain. My presentation today is about a serverless gateway for the execution of open machine learning models on AWS. The content of the presentation is based on 6 fundamental points: introduction, objective, architecture, use case, demonstration, and conclusions. Deploying machine learning models or artificial intelligence applications on on-premises servers face certain complexities, and servers require regular maintenance and cannot easily be scaled up on demand without downtime. In this sense, serverless computing emerged as a scalable and cost-effective solution to address the main resource provisioning challenge faced by machine learning users. Serverless computing is a completely self-management service in which the cloud provider manages the underlying infrastructure, so developers only need to focus on the functionality of their application. Therefore, the objective of the work is to design a server-based architecture that integrates models from existing catalogs of machine learning models already trained and publicly available with a serverless cloud computing platform. The platform has 3 fundamental components. The BAS API is a REST API written in Python that provides easy access to machine learning, deep learning, and artificial intelligence models. For our case study, it was necessary to develop a command line tool that would allow obtaining the prediction of the model, so we implemented the DBAS predict command. SCAR is the other component of the architecture. It's a framework for executing containers from Docker images in AWS Lambda to run event-driven applications. SCAR has 3 execution modes through which the prediction can be obtained, using AWS Lambda or AWS Bash. The last of the components is a user interface that represents the front end of the web-based architecture, allow users to obtain the prediction of machine learning models in a user-friendly way. Okay, the image shows the architecture of the platform where previously the administrator, through the SCAR client, create the function with the model to be integrated. Users can authenticate in the web through method, using their cognito credentials if they are deep users of the deep EM provider. Once the user has authenticated with the temporary credentials obtained from AWS, it is possible to interact with the files in the S3 bucket. Once one of the models is selected, when a file is loaded to the bucket, it requires that the function to be activated and the file to be processed in AWS Lambda or AWS Bash as specified in the creation of the function. The resource is stored in the output S3 bucket. The case study is made up of 4 publicly available models. There are 3 models from the deep catalog: an AD classifier, a plant classification, and a body post detection models. This model does not meet the space limitations of AWS Lambda. Therefore, they will run on AWS Bash. To implement the Lambda execution mode, we decided to integrate the Darner example to classify objects. Now it's time for a demonstration. On some startup time, I have recorded a video to adjust it to the presentation time. I will first comment on the administration part for the example of body post detection model. For the creation of the function through the SCAR client, 2 files are necessary. One is the script to be executed with the function, in this case, dpass.sh, and the other is the definition of the function, where it's necessary to specify the name of the function, the execution mode, in this case, the bash, because the image doesn't meet the limitation of AWS Lambda like I mentioned before. In addition, the storage provider for the input and the output files are defined. In this example, we use Amazon S3, where we define the path for the input and output files. To create the function, the command SCAR init is used, and the configuration YAML file is specified. After a few minutes, we should obtain that the function has been created successfully, like we can see in this part of the video. Okay, now, On the other hand, in the AWS console, we can see the service created through the Scar client with the command scar in. In Lambda, we have 5 functions related to our platform, one for each model, and the scar the pass list job function to check the status of the jobs that are executed in AWS Bash from the web interface. In the AWS Bash service, we can see the job queues of the 3 models that run in Bash, which are the audio classifier, the plane classifier, and the body post detection model. Finally, in AWS S3, there are 2 buckets that are used, one to store the web interface, in this case, ScarDpass UI, and the other bucket is to store the input and output file for each model. Within this bucket, there is a folder per model, and within each model folder, an input and output folder. Okay, now we'll comment on the user part. So this URL, you can access the web interface where it's possible to authenticate through the Cognito username and password or through the deep EM provider. In this case, we authenticate with the Cognito credentials. In the web interface, there are several sections where it is first necessary to select one of the available models. Once the model is selected, 2 information link appears. One with an example of the input file, in this case, an example of the body post detection model, and the other link is to the repository of the model to obtain more information about the model. The section to get the status of the job is only available for models running on AWS Bash that are long duration. For example, in the Darknet model that is in AWS Lambda, this section is not shown. There is also another section to review the input and output files in the bucket for the selected model. Okay, now we are going to proceed to load a file to see the output for the body post detection models, which is the one we have selected. Once the file is loaded in the input folder, we can see the file that we have just loaded. And in the job state section, we update and see how the job appears in runnable state. In this section, we have added an information link about the meaning of each of the state that a job can throw once it has submitted. Okay, this process might take several minutes and there is no provisional machine yet, so I will continue until I see change. After a few minutes, we see that there is already a provision machine and the job starts change to started. So we are there again. The job start is now running. Okay, the execution time, that is the approximate time from when the files begin to be processed until it is finished, is around 15 seconds. So we're going to do it again. And previously we had 3 jobs in succeed. Now, if we are there again, we can see that we have 4 jobs in succeed state, indicating that the job was processed successfully. In the output folder, we can see the result of the prediction. Also, this process took several minutes. If we have a provision machine and we load up another image, the process is more faster. The job goes directly to the running state, and after a few seconds, the process is completed. So we are going to date, and now we can see that the job is in running state. So we are there again. Okay, there again, and maybe 50 seconds until we have the result. Now we have the 5 jobs in succeed state. In the output folder, we have the 2 results. From the web interface, it is possible to delete and download the files from the bucket. We are going to download one of the results and we can see 2 files. Okay. Now we're going to open the folder. Okay, we have the output.json file and that give us the result of the prediction in JSON format. And in the image, we can see the points marked by the prediction of the model. Okay, now As conclusions, we can see that this presentation has introduced a serverless architecture to make it easy for users to invoke machine learning models through a web interface. The architecture uses AWS as execution backend, offering scale to zero to minimize service operation costs. The proposed solution constitutes a step forward in simplifying the execution of artificial intelligence model by end users. Okay, in this slide, you can see the name and contact information of or the author of this work. So if you have any question, you can contact with us. Thank you very much.